Felt like I could have been better with the shorthand on my last example number 9 because I was calculating a directional derivative, and there's a nice shorthand for directional derivatives. The directional derivative in the direction of, that's the hat, 3 negative 4 of 2x squared plus y squared evaluated at negative 1, 1. That looks like this. Okay. Is equal to, well, I think I'm going to need a new line. That is the direction of 3, 4 dotted with something. So 3, negative 4. And to have the direction of, I better divide by the magnitude. So 1 over, I'm going to switch to a small pen so I can get better resolution. Square root of 3 squared plus 4 squared. Okay. And that needs to be dotted with the gradient of this. The gradient of 2x squared plus y squared. And we just take that whole thing and evaluate it at negative 1, 1. So continuing, that is, let's see, 1 over 3 squared plus 4 squared. 9 plus 16, oh yeah, that's 25. So that's 1/5. So let's see, that's 3/5 and negative 4/5. This right here is a unit vector. It's a vector with length 1, and so it's a direction. A direction dotted with this gradient. Let's see, the gradient is derivative of this with respect to the first variable. It's 4x, and that's all. Derivative with respect to the second variable is 2y. And then we need to evaluate that whole thing at negative 1, 1. That is 3/5 times x, 3/5 times 4x, that's 12/5 x, minus 4/5 times 2y, that's minus 8/5 y. And that we evaluate at negative 1, 1. And that gives me negative 12/5 minus 8/5. Oh, that was not too bad. Let's see. That is negative 15 plus 8. Let's see, 23. 23/5. Or if you're allergic to improper fractions for whatever reason, I think I could write this as negative 4 plus 3/5. Okay, that's it. Let's see. The rate of change of 2x squared plus y squared in the direction of 3, negative 4, make sure you got the direction with a hat, at the point negative 1, 1 is negative 4 and 3/5. Okay, not too bad again. I mean, there's a lot of notation there, but it comes down to it, it's all reference to stuff that I've thought about before, right? The only thing new maybe is this notation for the directional derivative. Notice the period mark at the end. There's a perfectly good sentence, except for it violates a convention that I've talked about before. In good mathematics writing, if you're writing to your boss, if you're writing a textbook, try not to start a sentence with a shorthand symbol. Actually, that's good writing, whether you're writing in math or not. Try not to start a sentence with a shorthand symbol. It can confuse people. Shorthand symbols usually go into the middle. And D here is a shorthand symbol, and 2 right there is short for TWO, etc. Well, still, as long as you know the notation, it's a perfectly readable sentence.